Hey there folks, Mr. G here, back with another educational video. This time we're going to be talking about more trigonometry. In this case, we're going to be talking about special triangles. Last time we saw how we could take our angles in standard position and use those to calculate things like sine, cosine, and tangent. Now if you remember using these functions back last year in grade 10, a lot of times you would get really nasty values for sine of an angle or cosine of an angle. But for certain values of angles, what we're going to see is that the trig ratios have easy to calculate values. The first ones we're going to look at is what happens when our angle are multiples of 90 degrees. So I've put up four main examples that we see when we're talking about angles that are multiples of 90 degrees, 0, 90, 180, 270. If I went past this to 360, we would loop back to effectively 0 degrees. It would be on the same spot. And we've chosen our points here very specifically so that our radius r is always equal to 1. So we've chosen them so that r equals 1 in all of these cases. So let's do some examples where we find the value of each of our trig functions for different angles here. Let's start off with tan of 0 degrees. If you recall, tan is defined as y over x in this case. As we can see for our first example, x is 1, y is 0. So our answer for tangent is just going to be 0 in this case. What about tangent of 90 degrees? Well, it looks pretty similar. We've got a 0 and a 1, but notice here, y over x in this case, y is equal to 1 and x is equal to 0. So y over x would be 1 over 0. And if you remember, we can't divide by 0. This is undefined. So that's a little bit interesting. We actually don't get an answer for tangent of 90 degrees, or our answer is undefined in this case. What about cosine of 180 degrees? If you remember, cosine is the same as x over r. Now for our examples here, we chose them all so that r is equal to 1, x squared plus y squared. In this case, 1 squared plus 0 squared, square rooted will give us 1. And if we look at our example here, x is equal to negative 1 in this case. So our answer for cos of 180 would be equal to negative 1. How about our last example, sine of 270 degrees? For sine, it's y over r. In this case, our y is negative 1, and our r still 1 because of the way that we chose to draw our angles. And we also get sine of 270 is equal to negative 1. Now these are the really simple examples. Now it turns out there are triangles that we can draw where we can really easily calculate the values for certain very specific angles. We call those triangles special triangles, and I'll show them below. Our first triangle is going to be a 45, 45, 90 degree triangle. The way that we draw this is by starting off with a square so that each side is equal to 1, and then we draw a diagonal from one corner to the other corner, splitting our square in half. We know our corners here are 90 degrees, and since we're cutting this angle in half, this angle here is 90 degrees, but if we cut the angle in half, this should be a 45, and this should also be 45 degrees. Now if we want to use this triangle over here, we need to figure out what this radius is going to be, what our hypotenuse is, and we can just use Pythagoras for that. With a little bit of work, we'll get the radius is plus or minus root 2. Now, obviously, we're talking about a positive length here, so we're going to take positive root 2. Once we have our hypotenuse and our two sides of the triangle, we can state our trig ratios pretty easily by using the ideas of opposite, adjacent, and hypotenuse. For this, we're going to focus on this angle right here. The sine of that angle is going to be opposite over hypotenuse. In this case, our opposite side is equal to 1, and our hypotenuse is equal to our radius, which was root 2. Now I encouraged you to make sure to simplify these so you don't have any roots on the bottom. To rationalize the denominator here, we need to multiply the top and the bottom by root 2. And there's our answer for sine 45. For cosine, it's going to be our adjacent side over the hypotenuse. Our adjacent side is also 1. Our hypotenuse is still root 2, which we can, again, do the same thing as we did up here. Rationalize the denominator to get root 2 over 2. For tangent, it's opposite over adjacent. In this case, both our opposite and adjacent sides are equal to 1. 1 over 1, tangent 45 is equal to 1. The 30, 60, 90 special triangle. To draw this one, we're going to start with an equilateral triangle, each with side length 2. If it's an equilateral triangle, each of these angles needs to be 60 degrees. We know that the total amount of angle inside of a triangle is 180. We're splitting it into 3 equal pieces because we have 3 equal sides, so each of these needs to be 60 degrees. At the top point here, we're going to divide it in half so that each angle on each side is going to be 30 degrees, and we're also going to end up with a right triangle on each half here. Now since we divided it in half, this side length of 2 is now 1 and 1. The only piece of information we're missing is this length right through the middle here. I'm going to call it b, and we can use Pythagoras to figure out the length of this side. So our hypotenuse squared minus our other side squared. So our side right here we called b is going to be equal to root 3. Once we have the three sides of our right triangle, now we can just state using opposite, adjacent, and hypotenuse all of the different trig ratios. So focusing on this angle of 60 degrees right here, sine of 60 degrees, our opposite, which is b, over our hypotenuse of 2, would give us a value of root 3 over 2. Since b is root 3, our hypotenuse is 2, it's root 3 over 2. For cosine, it's the adjacent over the hypotenuse. Our adjacent side is 1, our hypotenuse is 2, so we get 1/2. For tan, it's opposite over adjacent, root 3 over 1, which is just the same as root 3. We're going to do the same thing for 30 degrees now, focusing on this angle up here. We're still using the idea of opposite over hypotenuse, but the opposite and adjacent sides have swapped because we're using a different angle, 30, not 60 degrees. So opposite over hypotenuse in this case, our opposite side is 1, our hypotenuse is 2, this would be 1 over 2. For cosine, it's adjacent, which is b in this case, root 3, over our hypotenuse, which is also 2. And finally, tangent, it's going to be our opposite side of 1 over our adjacent side of root 3. We've got a root in the denominator. We can get rid of that pretty easily by multiplying the top and the bottom by root 3. And there we go. So we've got 9 of these. We've got 3 for 60, 3 for 30, and another 3 for 45 degrees. These are all of our special angles. That's the end of our first video here. In our next video, we're going to be talking about how to do this if our angles are bigger than 90 degrees. Everything we talked about for our special triangles, it was 30, 60, and 45. How does it work if we have a bigger angle than that? See you in the next video.